Okay, so this is the wire and wetsuit problem where we start off with a perfectly horizontal wire and we add a weight, which is a wetsuit here, that's 3 kilograms, which weighs down the wire. Okay, so for the free body diagram, it's going to look a lot like the original picture with the two tensions and the force downwards. But we want to simplify this so that the tension has an upwards force and a horizontal force, so we don't have to worry about diagonals. To do that, we would split up the two wires in 90 degrees, where the horizontal will be the tension times cosine of theta, theta being the angle right here, and cosine because it's horizontal. So for the vertical, we would use t sine theta, and it's mirrored, so it'd be the same thing over here. And it's being weighed down at mg. Part 1 of the problem is finding the angle based on how it's weighed down. For part 2, the wetsuit is going to lose weight through drying, and we need to figure out at what mass the wetsuit needs to be for the wire to be perfectly horizontal and have the theta as 0.
So for the first part of the problem, we're going to be solving what the angle of this diagram is. So to this, we're going to use the Newton's second law equation, which is given by this equation up here. And we're going to first solve for the x components. So to do that, we're going to change this equation to be in terms of x. So we have the summation of the forces in the x direction times or equals the mass times the acceleration in the x direction. So once we have that, we're going to input all the values. So we have t cosine theta going in the positive x direction and t cosine theta going in the negative direction. So we're going to do t cosine theta minus t cosine theta. And this is going to equal mass times acceleration in the x direction. But since the problem is not accelerating to the left or right in the x direction, this is just 0. And then this is going to be 0. So there's going to be nothing in the x component. So for the next part, we're going to be solving for the y components using the same formula, but in terms of y. So once we do that, we have our components in the y direction, in the positive y direction, which is t sine theta. But since we have two of them, we can just make it 2t sine theta. And then in the negative direction, we have mg, so we'll just subtract mg. This entire thing will be equal to max, which is, or may, which is the acceleration in the y direction times mass. Once we have this, we can simplify to solve for theta, and doing this, we'll get m times g plus ay over 2t is equal to sine theta. Since we're not accelerating down or up in the y direction, we're going to have ay equal to 0, so this can just cancel out. Okay, so we're just going to take the inverse sign of this value over here. So we'll get theta equals the inverse sine of mg over 2t. Once we have this equation, we can simply plug in our values from the equation and solve for theta. We use 9.81 for the acceleration due to gravity, and we'll divide this by 2 times 60 newtons. Once we solve this equation, we get a number that is approximately 14.2 degrees. And this is equal to our theta.
Okay, so for the third portion, or the last portion of this problem, we're looking to find at which mass of the bathing suit will the string become horizontal or have the theta of 0. So, starting off, we need to adjust these, right? Okay, so we're looking for the mass, and we know that the theta of this equation is 0, right? and we are looking for mass. So as we derived from our last portion of this question, that 2t sine theta minus mg equals m acceleration in the y direction, right? So as we learned before, this portion, the mass times acceleration in y direction is equal to 0, right? So what we get is 2t sine theta minus mg equals 0. And then, we add mg to their side, so then we get 2t sine theta equals mg. And what we're looking for right now is mass, correct? So then we divide the g over, so we get 2t sine theta over g equals mass. So once you get our equation, then what we want to do is plug in our numbers, right? So what we get is 2 times 60 newtons times sine at 0 over g, which is the acceleration of gravity, which is 9.8 meters per second squared. That equals our m. So at this point, we notice is that we have sine of 0 on top, right? And a sine of 0, as we know, is 0, correct? So on top, in the numerator, we get 0, and in the bottom, we keep 9.81 for the acceleration of gravity. And this we know equals mass, and 0 over anything, as we've learned, is 0, right? So we get mass equals 0. So in the end, we learned that to get a straight horizontal or theta of 0, what we need is a mass of 0